All right, class. In this lesson, we are going to learn to write and solve compound inequalities. So before we begin, let's go ahead and define what a compound inequality is. And that is essentially an inequality made up of two or more inequalities. Okay, so that is a compound inequality. So let's go ahead and get started with the first example. So here we've got a number line, and the question is, how can you use inequalities to describe the set of numbers that's graphed below? Okay, and so what we're looking at is this red line going to negative infinity with a solid circle on -3, and then we have a open circle on 2, and then a line going to the right into infinity. Okay, so how do we describe this in terms of x? And so the way we would do this is say that x is less than or equal to -3. Okay, so let's pause there for a second. We're talking about less than or equal to, okay, because we have a solid circle on -3. So what that means is it includes the value of -3 and everything to the left or towards negative infinity. And so the way we express that is x is less than or equal to -3. Okay, so that means -3 is included in the solution, -4 is included, -5, -6.8, -9, okay, -24 over 5 is included in that value. Okay, so anything less than or equal to -3. And then if we look on the other side, we have this open circle, and so we're going to say that I'm going to also call it or, okay, because either condition can be true. X is greater than 2. Okay, so what this means is the number 2 or the value 2 does not belong in a set of numbers that's highlighted in red. Okay, but anything greater than 2, even the slightest bit, and anything greater than that is included. So this is how we describe this number line with a red dot over the -3 and the arrow to negative infinity, and then an open circle on 2, and then an arrow all the way to the right. Now let's take a look at another example. Okay, we have this number line, and we have a red dot on -4 and a line going to the right, but it actually ends on 1 with an open circle. Okay, so the way we're going to describe this is x, okay, it's going to be greater than -4, or greater than or equal to -4, and it's going to be less than 1. Okay, now some of you might be confused with this inequality sign. Okay, sometimes we read it from right to left, and sometimes we read it from left to right. In this case, we're reading this from right to left. Okay, so you see this open sign, or this inequality sign that's open. When you read from right to left, it's going to be greater than or equal to, and then this value. Now, if I were to read it from left to right, I would say that -4 would have to be less than or equal to the value of x. Okay, so in this case, we're reading it from right to left because we want everything that's greater than or equal to -4. So x is going to be greater than or equal to -4. But in this case, on the other side, we're going to be reading less than or equal to 1. So here we've got a value of, an open circle on 1 and going to the left. Okay, so that means my x value is going to be less than, or not equal to, but x is less than 1. Okay, let's move on to the next example. So here we've got example 2. We're going to solve a compound inequality that involves the word or. Okay, here's the word or. We need to solve this inequality. 5x plus 7 is less than 13, or -4x plus 3 is greater than 11, and then we've got to graph the solution. So let's go ahead and solve this first. We've got 5x plus 7 is less than 13. So to solve this, we're going to subtract 7 from both sides. When we do, we're left with 5x is less than 6. Okay. Then we're going to divide both sides by 5. And we're left with x is less than 6/5. So that is one of the solutions. Then we're going to move on to this second part. And we're going to go ahead and solve for x. So we have negative 4x plus 3 is greater than 11. Okay, now we're going to subtract 3 from both sides. And when we do, we're left with 4x is greater than 8. Okay, now we're going to divide both sides by negative 4. And now x is, now watch what happens. It's instead of greater than, it's going to be less than. Okay, notice that we switch this. Okay, and we switch it whenever we multiply or divide by a negative number. Multiply or divide by a negative number means we switch the inequality. So now we've got x is less than negative 2. Okay, so now if we were to graph this on the number line, okay, we'll have negative 2 over here and 6/5 here, and let's say the 0 is right here. Okay, now let's go ahead and graph this first. All right, we have a less than sign, which means we're going to have an open circle on 6/5, and then anything less than that will be part of the solution. Okay, and now let's go ahead and graph this one. Well, here we have an open circle of negative 2, and it's going to be less than, so it's going to go all the way to the left. Because this solution is part of this solution, which came from here, we won't need to graph this. Okay, and the reason we won't need to do that is because this is an OR situation. So as long as one of the conditions is true, then we are okay with this. So in other words, x less than 6/5 is a much larger set of numbers than x is less than negative 2. And since x is less than negative 2 is a smaller set, we won't need to graph that because the larger set already includes that. Okay? All right, so let's go ahead and move on to number 3, example number 3. Here we're going to solve a compound inequality that involves the word and. Okay, so the question here is, what is the solution of negative 12 less than or equal to 7x plus 9 less than 16? Okay, this is a little bit unusual because it looks like we have two inequalities, and that's exactly what we have. This is called a compound inequality. Okay, so to solve this, we're going to need to split this up into two parts. So the first part is going to be negative 12 less than or equal to 7x plus 9. And then the other side will be 7x plus 9 less than 16. Okay, so we're going to solve both of these and see what we get. So to isolate x, we need to subtract 9 from both sides. So we're going to subtract 9. And what we get is negative 21 is less than or equal to 7x. And then to isolate x, we need to divide both sides by 7. And now x is going to be greater than or equal to negative 3. Okay. Notice that we didn't switch the inequality sign here because we're dividing by a positive number. Okay. This negative number sometimes throws students off, but just remember it's what you divide or multiply by that requires you to switch the sign. Otherwise, you don't. All right, now let's look at this other part. So the first thing we're going to do is subtract 9 from both sides. And when we do, we're left with 7x is less than 7. Now we divide 7 from both sides, and we get x is less than 1. Okay. Now if we were to graph these on a number line, we'd have negative 3 here, 0 here, and 1 here. Okay. So let's take a look here. This says x is greater than or equal to negative 3. So we're going to put a closed circle on negative 3. And we're going to draw a line in this direction. Okay, we're going to just stop there because we need to take care of this. Here, this one says x is less than 1. So we're going to create an open circle on 1. So there'll be an open circle here. And because it's going to be less than 1, we're going to need to draw a line in this direction. Okay, so we're going to draw a line in this direction. And you notice that we stop right there. So the line is going to be in between, and that's because this is a compound involving and, right? Compound inequality involving and. So this is really, and I should have written this earlier on, it's going to be and. Okay, so when you have an and joining two different inequalities, both conditions must be satisfied. So this is why we draw a line in between this dot here and this open circle, and it doesn't go beyond those points. Okay, so the solution is within those limits. Okay, and I believe that's it. Hopefully that made sense to you. If any of this was not clear, please go back to the beginning of the recording and listen to this again. Thank you.